Hey everyone, welcome to this week's release of the Local Energy Podcast. Our guest this week is James Macnaghten, CEO of Caldera. And as we're going through this episode, we'll be referring to a couple things that he has designed, a couple of patents he's gone through. And if you want to get an idea of what we're talking about, I recommend that you head over to caldera.co.uk. That's caldera.co.uk. Link is in the show notes. But he's got a couple of videos on there, diagrams as well of what he's talking about. One thing we're talking about will be their electric storage boiler. So they take electricity, convert it into heat, and that gets used on these industrial units as they're trying to, heat things up at very, very high temperatures. So this is an amazing conversation. James is a fantastic guest. He's our first from across the Atlantic. So please enjoy the show. Man, I have another podcast I was running this morning. So let me start over. All right. I got to get the intro right. All right. Welcome to the Local Energy Podcast. My name is Peter Brecht. I'm here with my co-host, Wade Spear. And our guest today is James Macnaghten. James, again, I should have asked your last name, but I got that right, didn't I?
You got it right.
Thank goodness.
Most people start to say it and then realize they don't quite know how to pronounce it.
Right. It sneaks up on you. James Macnaghten, he's the CEO of Caldera. He's actually our first guest from across the pond. He's over there in Europe. Actually, I believe in Cambridge, correct?
I'm in Cambridge some of the time, but yes.
Okay. He's probably the smartest guest we've ever had on the show. And that's no shade against anyone else that's ever been on. But I mean, he's just gone through the ringer of education. So I'm very excited to catch up and learn about James. But Wade, I haven't seen you in like 2 weeks. So I got to just know, how is life in Oklahoma? And what have you been up to before we get into the rest of this? I got to catch up with you first.
It's been busy. Work's busy. We're continuing. We're picking up some rigs and, just staying working, which is a really good thing, So that's been good. And then family life has been crazy too. We just finished spring break here a week or two ago, and then going into the Easter weekend. So we got what, baseball games? We got baseball game tomorrow, 2 on Saturday, and then we're heading to go see family and everything on Easter Sunday. Yeah, so it's good times. How about for you?
Yeah, man, I've been same thing. So I was playing basketball, just I don't know, just a lot of that in school and then work and head down and keep going, right? So
is the weather good enough to where your wife's like pulling you out to go surfing or do anything like that yet?
I am no, I'm not gonna.
Okay.
She takes the kids. I stay on the beach. I'm fine.
All right,
Just
all right.
to like post up in the truck. And I honestly, what I've been doing is I've been trying to line up as many podcast guests as we can. And
Okay.
I've had this with James. We've had this scheduled for I think 2 or 3 months. So I'm excited. So James, over to you now. The very first question we ask all of our guests that come on is, and it's a simple question, yes or no: have humans landed on the moon?
Yes.
That question actually applies now that we
does.
shot off Artemis the other day. So
Did you watch the launch?
no, I didn't live. What about you, James?
I didn't watch it live, but you could hear the shock waves. It must have been amazing.
I think Elon Musk is probably wondering how they pulled it off before he did, because I don't know, maybe they have different agendas, but either way. All right, on to the next question. So you're a Cambridge engineer and you also own a tourist business. So my question for you is, which gives you more grief, the tourists or the engineers?
Totally the engineers.
Yeah. Okay, good answer. And you've got over 20 patents to your name. Is there one that you're most proud of?
They're literally the last 3, and they've been really good. So we filed we did a lot of filing early on in, I guess, my career, and I got pretty skeptical. I just thought the whole thing has wasted lots of money writing stuff out. And if you file a patent too early, almost always you haven't put in what's important. So this time round, we just delayed, we filed late. And then the other thing I've just been amazed is we've had a really good run. Early on again, I remember they come back and they say, oh, we got this prior art, or that if there's been sort of ideas published that have impact how original the idea is, then you're not having to have arguments. And this time round, it's just flown straight through. So it's been the weirdest experience.
Man.
So I would say I like these current 3 because they're giving me the least amount of grief.
Okay. So you've learned from filing the past couple, right? The past dozen or so, and now you've mastered how to file a patent properly.
You can waste the most enormous amount of money on patents and time.
Yeah.
But they're only valuable if they cover exactly what you're developing. And these days, I take the main value on them is just to make it difficult for other people to copy you.
Okay.
But engineers are inventive. You can often design around. So either you're developing it and it helps your business, but I never look at I tend to think of a patent as about 2% of the value these days.
Okay. Interesting. Well, if I ever get to a point where I have some invention, I'm going to give you a call. I'm not quite there yet, but I am a dreamer. So you have a very, I look at your resume and where you've been, but I would love to learn, walk us through from Cambridge, then to Isentropic, and then Caldera, which is your most recent, project. What's the common thread that kind of pulled you towards the energy storage world?
So I think just, I mean, I got involved in the tourist business when I was a student, and it's a great little business. It's basically, it's the boats on the river, but we have a lot of them and employ a lot of young people that take people on the tours, and we train them up, and it's a really fun business.
Yeah.
But I always loved engineering, and I sort of got back into it around Isentropic, which I think it was almost 20 years ago now. And at the time, lithium-ion batteries weren't a thing. I mean, they were so expensive, no one talked about it. And we had this idea for storing energy where you would basically use a reversible heat pump cycle to heat up rock. So you'd have a very hot pile of rocks, very cold pile of rocks. And if you reverse the process, you could, on a good day, get 60, 70% of your energy back if everything went very smoothly. And when we start, the idea was rocks are cheap, so you could store lots of hours. And I then used to joke by the end, not even the rocks were cheap. So when we studied, and what you learn is that there's such a huge difference between the cost of something and the installed cost. So my rule of thumb now is if you add up all the bits of equipment in a project, multiply it by 3, that's your installed cost. When we started, I think lithium-ion batteries were over $1,000 a kilowatt hour for the packs. When we wound up Isentropic, because it was quite clear we were too expensive, batteries were at $200 a kilowatt hour. And I think you can now buy cell packs out of China at $40 a kilowatt hour, thereabouts. And the materials are about $20 a kilowatt hour in China, but they're much more expensive everywhere else.
Interesting.
So anyhow, I got into energy storage, and so I got in there on the basis it must be valuable. And I think the hardest lesson I learned, and it took me a very long time to learn this, is it's really not very valuable. So it either needs to be extremely cheap or don't bother doing it, because a can of diesel or petrol is just really cheap. So if you want to store energy, to me, I don't understand a lot of the time why we obsess about, storing energy, trying to find energy storage batteries that'll last 2 weeks. I go, well, you just use a can of petrol for that period. I mean, I'm a great pragmatist. I had an epiphany. It was a pretty horrible one before we formed Caldera, but it was that fundamentally it's often just cheaper to build more renewables and throw the energy away, because that's often cheaper than storing it. So if you build more renewables, some of it you can use, that's great, you use it. The bit you can't use, you throw away, and that's cheaper than trying to create an expensive storage system to actually use it. And people are really, I basically realized that what we've been doing in Isentropic, in hindsight, which was a low cost storage, but relatively expensive to put the power in and out, and a relatively low efficiency versus lithium-ion batteries. I genuinely don't think systems like that have any value in the market. I describe it as, quite rudely, as, it's like owning a steam generating oil fueled power station in the UK, where you're at the bottom of the merit order, you never run. So the fact that it's cheap doesn't really matter. You never run.
Yeah.
I gotcha.
That's interesting. I had kind of connected that when I interviewed Meredith Englund. She's an author of Shorting the Grid, and she was talking about grid power and electricity. Like sometimes it's better to not even bid on it, because it's just going to go to waste anyways. But I never thought about it in terms of storing it. So that's quite an interesting thing to think about in terms of that. Isentropic. I want to make sure I pronounce it correctly, and maybe it's both ways, but so you developed large scale thermomechanical electricity storage. Is there anything from that you directly brought into Caldera, or is maybe Caldera's like, version 2.0 of it, or is it a completely different idea?
So there were 2 things we brought in that were absolutely key. The first one is never ever use air as a heat transport medium. So it might sound silly, but I'll talk about the piping. But we use steam to get the energy out of our system.
Right.
But
yeah.
I'm going to give you an example. Okay, so a nice sort of 5-inch pipe, I can get about 6 megawatts of heat through that in steam. If I wanted to move heat around at, I don't know, say 900, some people want to do high temperature stuff for cement and stuff, by the time I've insulated, you'll have 2 pipes for the same amount of energy. So with steam, it's like 6 inches there and it's like that big coming back with the water. I'd have 2 pipes that are about 2.5 meters in diameter each, and they will have to have refractory insulation on the inside. They will be insanely heavy, insanely expensive. And so my rule is like never use air as heat transfer medium. So we have steam because it's tiny, and when you boil something or condense it, you get amazing heat transfer coefficient. And then the second one was that when we built these enormous stores, and we internally insulated them. And I looked at them one day and I went, I think 50% of this very expensive store that was pressurized, 50% was insulation. I mean, so insulation is a really big deal. And I would also go, so we sort of designed, I always work backwards. So we developed the vacuum insulation because we started building a much smaller product. And then we went, this is really, so to sort of give users maybe think, we basically build, let's call it large industrial heat storage systems for factories. You put electricity in, you heat our material up. It looks like a big tank, it looks like a big silo. And we have a coffee cup over the top of it, which is like a vacuum vessel that we drop in. And the whole thing is, let's put it into feet, because, so we are, I don't know, 10 feet in diameter and 30 feet high, just as an approximate. And the unit weighs 100 tons, thereabouts, 110 tons. So and the key bit is the vacuum insulation is super efficient and it's really thin. So one of the things I learned was you can't afford to have 0.5 meter of insulation. It's expensive and it's also heavy. You end up with the insulation, and I joke about it sometimes, but you can end up with the insulation being not that far off the weight of the storage material, which is kind of crazy if you're trying to store stuff in, So I'd say that
how hard is it to create that vacuum? I mean, I would imagine that process for something that large is, I mean, that's probably a whole process in itself that maybe was never done. I don't know. Is that common?
So we're the only people that do this at scale, and we limit ourselves to 500 Celsius, which I think is about 930 Fahrenheit, something of that. That order. The reason most people don't do it is because historically gas is cheap and just didn't really care about heat losses. So people run furnaces. Most stuff at about 200 degrees, you don't need fancy insulation. When you go between 200 and 500, relative heat transfer becomes very significant. And conduction. So there's a whole things that bite you. So you end up either needing something really complicated that you have to fit on site, or it's all these panels that have to be overlapping. Whereas we basically turn up with this, as I said, it's a double-walled steel vessel. The insides do require a bit of care, but we basically turn up on site. You can't see my hands, but you turn it up this way, lift it up and put it on top of the store. So we can build the store, and my aim, we're not there yet, but my aim is that we can build and assemble a store in pretty much a day. That's the plan. You've got commissioning and everything else, but that's where I would like to get to. But I would say, so we always start on the design. We start from the vessel and then you work back in. So everything we think of has to fit within something that you can drop a cover over. It has to fit within a circular shape. So nothing we ever make is square. And I would say, so we thought about the insulation first. We think about how you get the heat in and out. And the bit that's almost the last bit is the storage material. It's not as important as people think, because you can have really cheap storage materials. There'll be people proposing, sand, bricks, stuff like this. Key is, how do you get heat in and out cheaply? And that is to me, the problem that is hard to solve. It's very easy to have a cheap storage material. It's very hard to get heat in and out easily.
There's a company called, it's Rondo Energy. I don't know if you've heard of them, but
I know Rondo.
They take their idea is renewable energy, and then they turn it into, they have these bricks that retain the heat, and then they're using that heat application for other things. One of them is enhanced oil recovery. So I know here in Bakersfield, Rondo, they do some enhanced oil recovery by injecting steam downhole, using the heat from that to then get more oil. Has that ever been, and I know we talked about oil briefly in the pregame to this, but has that ever been a thought, like, using this for enhanced oil recovery? Has anyone talked to you about that, or has that been sort of, and Wade's looking at me like, man, that's not even a question, but I'm curious.
No, it's a great question. I've worked at companies that ran those steam floods.
Yeah, exactly, yeah. But I'm just curious.
Okay, so
heat flow is so insane that I feel like there's an application there. I don't know.
No, but do you know Glass Point? So
I have not heard of Glass Point, no.
Okay, I don't know, I think they've resurrected themselves, but they built giant greenhouses in the desert with solar concentrators to do enhanced oil recovery. And one of the things is the ground is a great store of heat. So really, I'm not sure you need any storage. Why wouldn't you just put as much steam as you could get in during the daytime and then just let it sort itself out at night? And then the next day you could. So to me, I would think if you're doing enhanced oil recovery, I would just get solar panels, electric heaters, and I would just put twice as much steam in during the day and just let it distribute itself in the oil reserve or the whatever the tar sands at night.
That's a good point. Like, why stress yourself out 24/7? You don't need to, right?
You know, that's why I put. I was like,
Too hard.
you don't need storage.
Yeah.
I mean, you've just got the most enormous reservoir for storage. I just couldn't see why it would matter.
Yeah, right. Especially here in California where it's, sunny 300 days out of the year, right? So that's good. So based on my research, and maybe this number's off, correct me if I am off, or the stat, but industrial heat is responsible for 20% of the greenhouse gas emissions globally. It's something I never thought of, until actually learning about your company and what's happening. Any idea why maybe that's overlooked? Because again, that industrial heat, quite common. We just don't think of it because we don't see it typically. It's not, in our neighborhoods.
So the thing about industrial heat is it's split. So of that 20%, 40% is below 200. 8% of the total is below 200. To my mind, easy. It's kind of what I call, if you go up to maybe 500, it's roughly 50%. Then above 500, you're talking cement, steel making, glass making. It's like 1,000, 1,300. It's really hard. So when I say heat's not equal. The under 200 stuff, and I get really frustrated because everybody wants to go and decarbonize steel making, which is really hard. And I go, this is stupid. Why are we doing the hard stuff when we haven't done the easy stuff? I'm really clear. We're wasting so much time and energy trying to do difficult things when you go, but 10 years from now, we'll have better solutions. I mean, if you think I couldn't buy an EV 10 years ago, and now 50% of all the cars sold in China are EVs. I mean, it's just insane. If you tried to fix everything 10 years ago, you're just going to waste money because you're not going to have the right solution. So we don't need to worry about 2050. If you're interested, I mean, the audience may have different views. I think if we can, I personally believe we do want to decarbonize, but it has to be affordable and fast. And at the moment, we're doing quite a lot of, I would say, dumb stuff that doesn't seem to make sense. When if you can give somebody better quality experience for the same price without the emissions, why wouldn't you? So I go, so with industrial heat, the easy bits are food and beverage, pharmaceuticals, paper making, cardboard. They all just use steam as this equivalent of electricity. Steam's a really good way of moving heat around factories or big industrial sites. And then you go above it, and the hotter you go, the harder it gets. So my rule of thumb is everything above 500 is really hard. We're really clear. We go up to 200 Celsius, and I'm sorry I don't have that in Fahrenheit. But that's 10 bar. If people think of it as 10 bar, it's 10 bar steam. We'll go up to maybe 16 bar steam if you run a site. So it's the most common pressure range temperature for pretty much everything: brewing, distilling. Every can of beer you drink, every bottle of whiskey, bourbon, is that Scotch, whatever.
Yeah.
It's like it all uses heat.
Okay.
But to answer your question, the reason nobody has done anything about it is because heat's a lot less valuable than electricity, and gas has been really, really affordable, really cheap. So I regularly go into factories where they're getting better, but you just see uninsulated pipes. You'd see loads of things that, because it didn't really matter.
Okay. So there's some easy things we could work on first. And kind of reminds me sort of too about, you'd mentioned, hybridization of all this, right? So kind of not putting all your eggs in one basket. And I mentioned, here in California, it seems like we love to take away options from people, right? We want to, okay, you're only going to have this one utility company. We're all going to use battery storage. We're all going to drive electric cars, kind of taking away and that piece. But to your end of things too, I'd just love to hear kind of your thoughts. I'm a huge proponent of have as many options out there as you can. And if it comes from, or just power sources in general, right? We need gas, we need solar, we need wind, we need everything, right? And we can kind of switch between them. But what are your thoughts on that?
So, I look at this as a transition, which is you adding renewables to the grid. You're always going to get extra hours when you don't use it. We were talking earlier when I said it's often cheaper just to throw away the renewables, and that's not a bad thing. We pay to have gas power stations sit around doing nothing all year so that you can run them just when you need them for air conditioning in the worst time. So the fact that it's not running, it still costs you to have it. To me, surplus renewables that you don't use, not bad. My rule of thumb is once you start throwing away maybe 1,000 hours a year, it's sort of, you need to start increasing demand. You want to start using it at that point. If it's 1 hour a year you've got surplus, why would you put anything in just to run for 1 hour a year? So when it comes to about 1,000 hours, I think if you start to get up to 2,000 or 3,000 hours a year of surplus, it's going to get very expensive. So the way I look at the world is you basically want the demand and the generation to keep going up together. Flexible demand. Heat is just, so the reason heat is just really unusual, which is I generally think people hate doing things differently. I think it's really hard to change behavior.
Right.
But if you run a factory, you've got these big steam boilers, probably all running on gas. There may be 5 of them in a row. You're running 2 or 3, one's standby, depends on the time of year. Maybe 4 runs at the busiest time. They don't mind if we stick a couple of our units next to it. We can use on-site solar, it's cheap electricity. So when it's cheaper than gas, they just switch across because they don't have to change any of their processes. It all goes into the same steam header. So from the factory manager's point of view, he doesn't care. As long as the steam's there, he can always switch back to his boilers if there's a problem, or if electricity's, it's not as affordable. And to me, nobody has to change their behavior. So, and because heat is such a large amount of energy, this makes it a really great energy sink to use the renewable generation you'd otherwise throw away. So in Europe, where energy prices are much higher, I know perfectly well every factory, if you would offer them surplus electricity that we're currently throwing away because the rules don't allow them to buy it, if they would pay, if you offer it to them for less than the price of gas, they'll buy it. Market rules don't allow them. So at the moment, we pay people to produce it, and then we throw the whole lot away and we don't let them use it. So to me, this ability to flip, because it's called a transition for a reason. We're not meant to, by 2050, but if you just said, I'm going to run my factory on, electricity only, and you're going to bankrupt yourself, because it makes no sense. There'll be times of year when it's just really expensive and you want to flip back to gas, oil. And to me, therefore, hybridization is the obvious way forward. It also provides more resilience. Factories like, we've seen with the Ukraine war, we've just seen recently with Iran, energy prices can move around an awful lot. And sometimes having a, 2-year contract with a utility is a really good thing because you're now hedged. You might be like, crikey, I'll just start using more electricity because my gas price has gone up faster than my electric bill till it catches up. So I think hybridization, and people love the idea of having something 100%, clean. But to me, that's almost always is much, much more expensive than just being pragmatic and saying, I'll do 20%. We'll get to 20% here. We'll do another 20% then, and we'll see where we are. And it may well be that there are not good solutions and you don't go beyond that, because one of my points I said it's got to be affordable.
Right. Yeah. I love your framework on that. I love everything about that. And that's kind of where I've been thinking through things too.
One question I've kind of got is how much, I guess my question is how much R&D goes into kind of what you're doing or in your industry right now? Do we feel like we've got a lot of the answers solved, or is there still a large percentage of kind of budgets and CapEx and all this stuff being poured into gaining efficiencies and, whether that's figuring out new mediums or storage capabilities? I guess where my question is really going is like what I feel like I've seen in the oil field, or at least here in some of the United States, is like as like diesel and things like that become expensive, right? Like with gas prices going up, with everything going on in the Middle East, it feels like all of a sudden more money goes into research and development on alternative energy sources and how to be more efficient in that way. But as soon as things get cheap again, we go right back to, just a pure diesel burn and everything else. So do you see that happening with you as well, or?
I don't have a particularly good US view, but in Europe, I would say it's relatively hard to fund projects as well as US companies. You mentioned Rondo. I think they've raised $200 million. It's very hard to do that in Europe. We don't have the same, appetite scales. I personally think government should give everybody developing technology huge amounts of free money to help them along the way, because it's unbelievably hard. And as long as you've got investors coming in alongside you, that should be all the government need to know. Because while it appears to be spending lots of money, what we actually spend billions on is subsidizing offshore wind or onshore wind, or putting in frameworks. In Europe, they have, what we call contract for difference, which is where you guarantee an offshore wind farm or, a fixed price. And the government do it to, allow to manage the risk. But fundamentally, we put so much money into later stage technologies with these sort of method, actually what you spend on the early stage is tiny, but 98% of it is going to fail. That's the other thing, I think. And governments are terrified of, do you remember Cylindra? I think it got 400 million of loans. It was like this circular, it was their California company, I think it was Cylindra, but they had these circular PV collectors that were just insane. And they got given a whole lot of money. And of course, the government got really hit, the US government got really hit for having done it. But it's like, because then no one's honest, going, almost all of this money is going to be wasted, but the 2% that's not is fine. It's still a good, because if it was a 5% or 10% success rate, VCs will step in.
Gotcha.
Right. It's yeah, honesty is difficult to come by these days, I think, in some certain political regimes, at least here in California. But that's a whole nother conversation. Like, and I'm just saying honest, like, let's look at the facts and, make good decisions based on that. But that's a good, yeah. I mean, Wade, that's a good thing though. I was thinking, like, oil prices where they're at, but no one, at least from what I can tell, is really making, like, we're not drilling more right now. I mean, is a lot of that going to R&D? Is that what you're saying?
No, like what I've historically seen is whenever I think about this specifically, I'm thinking like 2012 through 2014.
Yeah.
Diesel prices were just going through the roof, right? And what do frac spreads and drilling rigs burn a lot of? We burn tons and tons of diesel every single day.
Yeah.
So what you start seeing is big pushes during that time of like electrification of rigs, or kind of what you're mentioning, James, like biofuels. It's like, oh well, hey, we can run on. Yeah, I mean they've even got like LNG type of equipment to where you deliver LNG out there, and then that you feed that into the generator, which then gives you power. And so it was always interesting that like during that time there was a lot of money that went into these like electrified frac fleets, and they're still hanging around now, but they're not used very often because of the cost of them, because diesel was down at $2, but now that diesel's running back up to 375, 425, 450 a gallon, you start hearing those conversations being revived. And so it's just interesting to me that it seems like, high prices really kind of push you towards that alternative energy source. But then as soon as much money goes there and the prices come back down, it's, I don't want to say abandoned, but it's not nearly as applicable or employed. So no.
You're not going to believe this, Wade, but the price of diesel right now. So every day my wife drives by the same gas station, takes a picture of it, and sends me a photo.
California, yeah.
Diesel is $8.19 a gallon. It is, I can't believe it. I can't get over it.
I mean, I don't drive a diesel truck, but I get updates from the rig all the time, because we're using like dyed, we're using dyed diesel. So,
yeah.
So it's even cheaper, but $8 something a gallon's insane.
Yeah. So James, moving from the engineering side now into the CEO side and the business growth and all that, you have on your website. So GEA invested in you guys about a year ago. I'd imagine that unlocked a lot of great things, whether that's capital, distribution. I don't know. There's a lot of things that go along with that sort of partnership, but what was the biggest change or benefit from having them on with you? I mean, obviously that's a huge thing to have in pocket there.
It was quite an interesting, because they're a strategic investor. So, and they have a long-term interest in us. So GEA, they're a big German DAC 40 listed company. I believe we're the earliest stage company they've ever invested in. And if you are, I don't know, probably, a large, I probably shouldn't say any names because but they're pretty much anyone who, your Red Bull or something like that. If you want if you want a production line that has like zero, they basically will build you an all electric heat pump integrated system. And they're looking at factories, so brewing, distilling, they're looking to go in and replace the boilers because a lot of these processes have fundamentally a heat pump recycles heat from a lower temperature up to a higher temperature. But if you think about a factory, everything goes into the factory cold and it comes out at the same temperature. All of that energy you've burned. So it's like distilling as a process. Fundamentally, you're just boiling something, condensing it, a few degrees higher, and you can just recycle the heat. You don't need to just add more heat all the time. Now, so there are a lot of processes where putting heat pumps in makes loads of sense. But heat pumps but a lot of these processes like food and brewing, they're batch processes. So heat pumps like to run steadily. GEA make heat pumps. They do the whole system. But where you get these sort of spikes when people open a steam valve, suddenly the steam pressure drops. In your traditional factory, the boilers, all the burners would turn on. This is a hard thing for a heat pump to follow. Our product fits in really nicely because it's exactly what we can do. So we manage what I call the peaks, the spiky stuff, but we don't do a lot of energy shifting alongside the heat pumps. So they see us very much as part of the final the solution for the now with a heat pump, you put in 1 unit of electricity and you maybe you get 4 units of heat. So effectively you're moving 3 and you add the unit of electricity that you're putting in as well. With our system, I go, well, if you can charge in the 3 cheapest hours of the night and they're a third of the price, you have what I call an economic COP. So pretty much all the sites we look at where you can, we only have to charge in a few hours, and we do a lot of managing the power. I sort of describe this as power management. You get a really good payback. Now, it depends on the grid rules. It depends on how expensive electricity is versus gas. It depends on how much renewables there are. So if you've only got a little bit of renewables on your grid, the price of electricity is just going to be flat. So we work really well in worlds where there's either too much generation, or frankly, you've got demand side issues, like the demand is very spiky and you've got a small grid connection. So we like variability. Whenever we come across sites where it's really, the heat load is really flat or the electricity price is really flat, there's no business case for us in that. But it's rare and becoming rarer, because everywhere we look, you just see renewables is now, particularly solar, is just the cheapest form of generation.
Yeah, gotcha. And when we're done recording, it's evening over there, so you're gonna be done with recording. You're gonna head to the pub. What is the thing that you're thinking about with Caldera when you're not on the clock per se? I know you're probably never not thinking about something, but what's that thing you'll sit down and kind of start thinking through potentially?
So we're starting. We've got our first deployments happening this year. We've got 2 units going into a hospital. We want to get to a stage where we can deploy hundreds of units a year. Now, that's going to take some time, but when you get into the industrial space, I think one of the things I hadn't fully appreciated is it's just a very long sales cycle. So you want partners and investors that understand this. So we sign a contract and, you'd be looking to deliver within a year, because they might have to do something for the electric network on site. We might need a new transformer. All of these things take time. And so I would say I would like us to go faster, but I also fundamentally believe if you put the wrong product out, you never get over it. So it's really easy to rush just to get something out. And I would say VC investors are particularly bad at insisting you get, the first product out, and then you spend the next 5 years trying to fix it in the field with a very unhappy customer. I think it doesn't it's a sort of, I don't think it works for hardware. Whereas we have actually, funnily enough, we deployed, I think, 12 of our units into homes. We've got a lot of running hours at smaller scale, and it taught us the most huge amount about deploying. And most of the issues it's not the cost of the product, it's the cost of putting it onto the site, connecting the electrics, connecting the steam. Always these sort of install costs actually are much greater than the product cost.
I can't imagine the project management on that. That's got to be.
It is intricate, and I luckily don't have to do it.
Fair enough. I think that's, you get to just get the right people in the room with you and make it happen. So in 10 years from now, if you were kind of like looking out, and I know this is sort of hypothetical, but what do you think we'll be talking about in 10 years in the energy space?
I think oil demand is going to crash. I think it is, if you work out so we had the number of petrol cars in the world, I think peaked about 2022 or 23. So it was still going up like this. We've hit the point now where China is putting fewer petrol cars on, the number of electric cars going. And when you sort of start to do the maths and you run it out, you find that there's about 20 to 30 million barrels a day of oil demand that disappears in about a 10 or 15 year period.
Okay.
So,
I wouldn't have
I think the world is going to look very different. Despite all the publicity, people prefer driving electric cars. I love it. I mean, I just never go to a gas station these days. I get home or get to work. It's just so simple. I'm not a car person, by the way. So, I don't, I have lots of friends who are very, but for me, it just drives me around. So I think people prefer electric cars. I think, and for so many applications, home solar, you might hear about things called balcony solar, which we're just doing in the UK, but in Germany, you can just hang a couple of panels off your balcony and plug them into the socket, and you're allowed to do this. And it's so cheap.
Wow.
I mean, solar is just crazily cheap. So I think solar and battery, I think batteries and solar will get together pretty much all the time. And I think we're going to start to see semi-base load power from solar and battery installations. We've seen it going in the UAE, but I would say the southern part of the United States, so Nevada, California, Texas, all that strip across the bottom. I just think you're going to start to get power stations that are run by solar that generate for about 80 to 90% of the year continuously.
And do you think that will continue? I mean, if you look at the energy demand from AI, is that, I don't know if that's, I know it's going up rapidly, but I'm sure that'll plateau at some point. Do you think that's the case even with AI continuing to consume as much as it is?
That gets you onto a slightly bigger question about whether what happens if the AI bubble bursts.
And right, I think about that too.
So to me at the moment, it's going to be like, I don't know, when Atlantic Crossing went bust in whatever 2008 or 9, they were all the fiber. We had enough fiber for the world. No one built any more fiber optic connections subsea for like 8 years, I think. I think we're just going to build the most enormous number of data centers, and then there'll be no one to pay for them, and no one's going to build data centers for 5 years.
Interesting.
Fundamentally, I'm sure AI will take an awful lot of power, but somebody has to pay for it. There's only, my maths works back that, there's a billion people in the world with money. There's 100 million that are in well-paid jobs, and every one of those 100 million would have to pay an annual subscription of $40,000 a year to the big seven to justify their market cap. And so I think most companies object to paying $400 an employee. So if you work back, you go, there's a factor of 100 missing somewhere.
Right.
So if it carried on at the current rate, I'm sure it's going to put an enormous amount of stress onto everything, but I don't understand how it can. Sooner or later, surely the economics have to catch up with the whole process.
I love it. That's a very good thought. You raise a good question on there. Is like, where is the AI piece heading? But I think of that in the data side, because that's predominantly the headlines are there, right? We're using so much power. We need more. We need more. At some point, I'm even finding myself. Wait, I don't know about you, but I've sort of built out like as much as I possibly can already. Like, I don't know what else to build right now. I'm sort of kind of hit a wall. I don't know, but maybe we're there. Anyways, guys, thank you. We'll kind of move to wrap up here. James, I'll make sure we put your company's website in the show notes and your LinkedIn. Is there anywhere else that people can reach you, or are those the two best places?
So LinkedIn, yes, I love LinkedIn.
Yeah.
And I was just going to ask in the show notes, if you could put a picture of it's like, we haven't really talked about it. If you could put a picture of the heat cell with like, this is what a heat cell looks like.
Yes.
It was probably
they're really cool looking.
People.
Yeah, they're super, they're clean looking. Like, it doesn't look industrial. It looks very much like it looks modern. It's awesome. The design even looks incredible. So
thank you. I have a real hatred of boxes. I pretty much, it's like, the strapline for Caldera should have been, Caldera, you will, no boxes here.
I love it. Awesome. Well, James, thank you so much. I love talking with you and learning about what you do. I hope we can stay in touch. I'm going to be reading your LinkedIn articles, but we wish you all the best as you continue building. And we'll cross paths again, I'm sure.
Peter, thank you. And Wade, great to meet you both. Been a real pleasure.
Nice talking to you.